Guys, I tried and failed. Let's go back to the platformer. It would be a shame if I had to say that, right? You don't know what I'm talking about? Well, if you haven't watched the last video, it's not too late. You still can. But if you don't want to, I'll give you a quick recap. I originally started building a platformer because I didn't really have a concept. I just wanted to get going and that was fine, but I also wasn't super excited about it. So 2 weeks ago, I decided to put some thought into what I really wanted to build, and I decided to mix elements from games I like to play. My vision was to build sort of a race game similar to Micro Machines with skateboarding elements from Tony Hawk's Pro Skater. That sounds like a lot of fun to me, but the big question is, how's this supposed to work on a 386? Obviously, it won't without compromises. 3D is off the table and the next best thing probably is an isometric view. It's still 2D, but it looks 3D, it's still tile-based. How hard can it be? That's what I wanted to find out. So I read up on isometric maps. Spoiler, I should have read a bit more, but I'll get to that. And quickly had a diamond-shaped map on the screen. But having a race on this tiny diamond wouldn't be too exciting, right? So I increased the map size and shifted its origin to fill the whole screen. And that worked pretty well, but I noticed that rendering the map was way too slow. I didn't even need benchmarks to see that my implementation had two problems. Shifting the origin still meant iterating over the entire map. Sure, the draw method didn't actually render tiles that were off-screen, but every loop iteration and every method call still costs precious cycles. But even after limiting the drawing area, it was still painfully slow. And that was because of transparency. Well, more specifically because of my draw alpha method. To give you an idea, here's a version that uses the draw method instead, and it's basically 14 times faster. So why is draw alpha so slow? Let's compare the two. To draw a 32 by 16 tile, draw performs 16 memcopy operations, 1 per line. Draw alpha, on the other hand, does 512 put pixel calls. So the answer is, I went with the simplest implementation and never optimized it. I had read about transparency encoding in this book, but I didn't like his approach, so I came up with my own encoding. If a byte is greater than 0, it means draw this many pixels and the next bytes contain the actual color data. If it's a 0, it can mean one of two things. If the next byte is greater than 0, it's a run of transparent pixels. If the next byte is a 0, it marks the end of the line. With this encoding, draw alpha just had to follow simple instructions. Draw pixels, skip pixels, go to the next line. And sure enough, performance improved to about 10 frames per second. I'm not gonna lie, it bothered me that it was only 10, but at that point I didn't know how to push it further. It was only while working on this video that I wondered, why do I even have to keep track of transparent pixels? So I came up with a new encoding. X position, Y position, length, followed by the pixel data. And that made everything simpler and also faster. The next step was to get smooth scrolling. The mechanics were basically the same as in the platformer, but going from pixel to tile coordinates was a little harder than expected. And by harder, I mean I didn't get it quite right. It kinda worked, but it was also off sometimes. I have to say I really suck at math, and at some point I gave up and started looking for solutions online. To make a long story short, most formulas looked similar to mine, so I guess I'm not a complete moron, but they were also off sometimes. I'm still not sure what the problem was, but I guess I was doing something wrong. Then I stumbled across a forum thread where someone asked the same question, and the first response was, it depends. Are you using a diamond or a staggered isometric map? And I was like, what's a staggered isometric map? Turns out it's basically what I was already looking at, a rectangular map, but rectangular by design, no need to offset and crop it. And the tiles are laid out in a straightforward way. So to make another long story short, I was able to reuse most of my old map drawing code, and the only real change was offsetting every other row, and it basically just worked. So I wasted a lot of time with this diamond-shaped map only to throw it away and use what I already had. Maybe I'm a moron after all for not seeing the simple and obvious solution, or at the very least, for not doing a bit more research up front. Now looking at the final version, it doesn't look too bad, but also not too great. Every time the buffer area gets redrawn, there's this little stop, and that's not exactly smooth. You may also notice that some lines change color occasionally, and that's another side effect of redrawing. In an isometric view, tiles that are below others are technically in front of them, from a 3D perspective. That means when you redraw one tile, you also have to redraw the tiles directly below it, which means you have to redraw even more tiles. So redrawing a single tile basically starts a redrawing avalanche. And if there's one thing I know, it's that this is not gonna work. I don't know how to solve it, and maybe I won't, but I also won't give up just yet. Make sure to tune in next week. I'll see you then.